Listen. No waves. No wind. No shoreline noise at all. This water is so impossibly calm, it feels less like a lake, and more like a massive, open eye. Crater Lake doesn't act like something peaceful. It acts like something watching. The water? Clear enough to see 100 feet down. But clarity is the distraction. Because beneath that stillness sits a volcano that never died. It's been 7,700 years since the mountain collapsed. Long enough for the caldera to cool, fill with water, and for the magma chamber beneath it to begin rebuilding. That calm you're seeing? That's the part designed to fool you. If you were standing on the rim, would you trust this water? Yes or a no? Type it now. Crater Lake looks calm, almost sacred. A perfect bowl of sapphire water, so clear you can see nearly 40 meters down. But that clarity isn't purity. It's the silence left behind after something dies. Because this lake wasn't carved by glaciers or rivers. It was born when a 12,000-foot volcano collapsed in on itself. A mountain folding like wet paper. What stands here now used to be Mount Mazama, one of the most powerful volcanoes in North America. And then it blew itself apart. 50 cubic kilometers of magma erupted, blasting ash and pumice across 8 states. The entire summit fell into the empty magma chamber, creating a yawning hole more than 2,000 feet deep. A wound so large the earth never stitched it closed. No rivers feed it. No streams escape it. The crater is sealed, hydrologically isolated from the world. So water here has only one source, the sky. Centuries of snowfall and rain slowly pooled in this volcanic scar, creating one of the purest lakes on Earth. So pure that almost nothing grows in it. Which leads to the first mystery. In 2021, something strange appeared. Bright algae blooms, floating like emerald smoke beneath the surface. Not pollution, not runoff. This lake doesn't get runoff. Scientists still debate whether it was a rare nutrient pulse, a shift in circulation, or something deep within the caldera stirring the chemistry. If nothing flows in or out, how does a sealed crater suddenly support new life? We'll come back to that. But first, your question. How long do you think it took rain and snow alone to fill a 2,000-foot deep crater? Drop your guess in the comments. I'll reveal the answer in the final section. If Crater Lake were just a pretty basin of rainwater, the story would end there. But the real danger isn't the water, it's what's under it. Because the volcano that collapsed to create Crater Lake, it never went extinct. It simply changed shape. But deep below, the mountain is still alive. Beneath the lake is a patchwork of faults, fractures, and magma pathways. Like a broken ribcage wrapped around a beating heart. Nothing on the surface hints at it. No steam vents. No sulfur pits. No telltale tremors. We know this because deep lake surveys have documented hydrothermal vents on the caldera floor. Bacterial colonies clustered around heat sources where water temperatures spike 60 degrees Fahrenheit above the surrounding depths. A restless hydrothermal system, venting heat, dissolving minerals, cycling gases through fractured rock. Pressurized, but sealed beneath 2,000 feet of water. And the silence is the problem. Active volcanoes warn you with steam vents, sulfur emissions, constant tremors. Mazama lacks these telltale tremors. Silent ones like Mazama accumulate pressure beneath the surface until the system fails all at once. So here's the question. If you were monitoring this caldera, what would worry you more? Hydrothermal heat spikes, or the fact that there are no earthquakes at all? Drop heat or quakes in the comments. Because the lake sits inside a geological choke point, a sealed basin directly above a magma reservoir. Any pressure that forces a pathway upward amplifies the system. Imagine 4.6 trillion gallons of perfectly clear water. If magma breaches the lake floor, even at a single point, water flashes to steam instantly. The localized explosion throws superheated water, ash, and volcanic rock miles into the air. The sealed walls amplify the blast, turning the lake itself into a massive accelerant. And unlike Mount St. Helens, which erupted sideways, visible for miles away, Mazama's next eruption would start underwater. Invisible, until the lake itself explodes. But there's an even stranger clue that Mazama is still alive, something hidden inside the water itself. Not the clarity, not the depth, something trapped between invisible layers, deadly and misunderstood. We'll dive into that next. Crater Lake looks calm, blue, serene, too perfect to be real. But beneath that glassy surface lies a deadly trap. Because this isn't just water. It's a layered system, a natural stratification of temperature and gases, trapped in a deep, sealed crater. The top layer, cold, fresh, oxygenated. Below, warmer water carries dissolved volcanic gases. 38 degrees Fahrenheit at the bottom. 55 degrees Fahrenheit at the surface. Between them, invisible boundaries where the water refuses to mix. Under normal conditions, Crater Lake is safer than Lake Nyos because seasonal overturn prevents deadly gas buildup. Every winter, cooling surface water sinks, mixing the lake from top to bottom. The gases escape gradually, harmlessly. But here is the geological nightmare scientists fear. The hydrothermal vents beneath the lake, Section 2, could disrupt this cycle. Heat from the magma could stabilize the bottom layers, trapping CO2. If climate warming continues, reduced winter mixing could allow decades of gas to accumulate. Only then could the lake become limically unstable. If that happened, the lake doesn't just bubble. 1 minute, it is placid. The next, supercharged volcanic gases flash erupt. The water surface doesn't just boil, it erupts violently, flinging water skyward while CO2 suffocates everything below, like a violently shaken soda bottle large enough to blanket the entire landscape. Scientists have studied Lake Nyos in Cameroon. When its gas-saturated water erupted in 1986, it released between 100,000 and 300,000 tons of CO2, killing over 1,700 people in minutes. Crater Lake's volume? 4.6 trillion gallons. If the lake ever stopped mixing, if climate warming permanently stratified the water, even a partial overturn decades from now could trigger disaster far beyond the rim. If you were standing at the rim, where would you run? Higher up the slope, or away from the crater entirely? Type up or away in the comments. The water you admire could, in an instant, turn against you. But the people who lived closest to this place understood volcanic danger millennia before science did. Their warning wasn't written in a report. It was a battle told in ash and fire. The lake we see today was born from this battle, a silent monument to what the Klamath witnessed and survived. Long before science could measure temperature layers or track hydrothermal vents, the people of this land observed the signs. They understood a mountain's calm surface could conceal a force capable of unimaginable destruction. The Klamath said Leo's throne collapsed into the underworld. Geologists called at the summit of Mount Mazama dropping 5,000 feet in a single day. They described red-hot rocks as large as hills hurtling through the sky. Volcanologists call that pyroclastic ejection. Different words, same catastrophe. The Klamath didn't fish at Crater Lake, didn't drink from it, didn't camp near the rim. The lake was Jaiwa's, sacred ground where only spiritual leaders could approach. Not out of reverence alone, but out of memory. This place had killed before. So here's the question. If your ancestors told you a place was cursed, would you listen? Type yes or no in the comments. The lessons embedded in these tales weren't just myth. They were warnings, describing an event that science would only confirm and date millennia later. What the Klamath understood through story, modern science confirmed through monitoring. The mountain never stopped being dangerous. It just learned to wait. And now, we can model the next eruption, map where the danger zone extends, calculate how far the destruction could reach. The calm of Crater Lake is a perfect disguise. Beneath the surface, the mountain is still alive. Hydrothermal vents pulse with heat. Layers of water trap energy. The sealed caldera walls amplify any explosion, creating a system primed for devastation. And there's a critical factor unique to Crater Lake. 4.6 trillion gallons of water sit directly above the magma chamber. When superheated magma breaches the lake floor, the water doesn't boil. It explodes instantly. This is called a phreatomagmatic eruption, and it's the most violent interaction in volcanology. The lake itself becomes a weapon, amplifying the blast far beyond what a land-based eruption could achieve. Using modern monitoring and computer modeling, scientists can predict how far Mazama's fury could reach. Terrain, wind patterns, ash density, and water displacement all factor into these simulations. Pyroclastic flows could sweep down valleys at speeds exceeding 100 miles per hour. Some flows have reached 200 miles per hour or more, faster than any evacuation could outrun. Lahars, muddy torrents of volcanic debris, could bury entire towns in minutes. Ash plumes would rise tens of thousands of feet, drifting across the continent, disrupting climate, transportation, and agriculture. Mount St. Helens, the most destructive U.S. eruption in modern history, leveled everything within 19 miles. Mazama's caldera is 3 times larger. The eruption 7,700 years ago ejected 50 cubic kilometers of material, one of the most powerful volcanic events of the Holocene. So here's the question. How far away do you think you'd need to be to survive the initial blast? 10 miles, 50 miles, 100 miles? Drop your guess in the comments. Every simulation underscores the same unsettling truth. the mountain never forgets. Modern science gives us the ability to quantify the threat, to map the consequences, and model the devastation. But the greatest danger isn't the blast itself. It's the quiet clock of geology that ticks on, oblivious to our lifespan. Even with technology and AI-driven predictions, the scale is staggering. Terrain models, remote sensors, and real-time data allow for early warnings. But history reminds us, one miscalculation, one overlooked factor, and the mountain will reclaim its power. Crater Lake looks calm, blue, serene, too perfect to be real. Remember that question from the beginning. How long did it take rain and snow to fill a 2,000-foot deep crater? 740 years. That's how patient nature can be. Centuries of accumulation, drop by drop, until a wound became a lake. And if the mountain erupts again, the water that took centuries to collect could be vaporized in seconds. Time here is measured differently. One heartbeat of a human is a fraction of a moment from Mazama. Its clock ticks in centuries, not seconds. You looked at this lake in the beginning, and your brain said calm. That's the evolutionary trap. Clarity isn't safety. It's just surface level enough to fool predators who only understand immediate threats. Mountains operate on a scale far beyond human perception. The danger of monitoring a mountain like Mazama isn't reading instruments, it's interpreting silence. In 2024, seismic networks recorded 0 volcanic earthquakes under Crater Lake. Every thermal scan came back normal. Every gas sensor showed baseline readings. That sounds reassuring, until you remember we've only been monitoring for 40 years inside a volcanic system that operates on 10,000-year cycles. Silence doesn't mean safety. It might just mean we haven't been watching long enough. Because the Klamath understood this long before we had instruments. Their memory of the mountain's wrath recorded what science now confirms. Mazama never forgot, and neither did the land it shaped. Its ultimate lesson is written not in papers or reports, but in the rhythm of the earth itself. Next time you see something in nature that looks impossibly calm, remember what calm can hide.